Greetings, everybody. It's a pleasure to be here today to present our innovative technology to you all. Modern electronics manufacturing has come to a true inflection point in our world. The next step in this technology is being driven by revolutionary demand for flexible, high-performance electronics. It wasn't too long ago that traditional printed circuit boards met nearly all the world's needs for electronic circuitry, but they could not flex. They added weight to devices, used a great deal of energy, harsh chemicals to manufacture, and were capital intensive. They were not suitable for the next generation of devices. The result of this was the birth of flexible hybrid electronics. Flexible hybrid electronics has solved most of the issues, but making strong, electrically reliable interconnection between circuitry and devices has remained an issue for our industry. Conventional adhesive options for attaching microchips and components to flexible circuitry while requiring fine pitch alignment cannot withstand the rigorous flexing and stretching of some of the types of devices our industry is trying to develop. The solution that we present is ZTAC Ace anisotropic conductive epoxy from SunRay Scientific. With our patented formulation and process, we can grow columns of microscopic wires, creating fine pitch Z-axis interconnection between devices and circuitry on a wide range of substrates. ZTAC can work on traditional printed circuit board, printed copper flex, printed circuitry on PET, and even on TPU and other difficult to adhere to and perform substrates. It can manage a pitch down to 100 microns with high density packaging, improved adhesion up to 5 times that of traditional ECAs, and in most cases does not require either an underfill or encapsulation to protect. In processing, we do not require a heated thermode or pressure and can be cured as low as 80 degrees C and requires little to no CapEx with the ability to run on most existing SMT lines. ZTAC Ace offers the ability to enable a wide range of interconnect solutions from leaded components, flip chip and bare die, chip stacking, and ultrafine wire attachment. But all this doesn't come without a little magic. So how does ZTAC work? Our IP is based on an innovative ferromagnetic particle that we've developed, which is randomly dispersed into a 2-component polymer epoxy system. Once applied, devices are then placed onto our ZMAG magnetic pallet, which immediately begins to align these conductive particles into a Z-axis direction as it carries those parts through the traditional reflow oven used on all SMT lines today, or with our soon-to-be-released UV-cured ZTAC formulation through your traditional UV curing unit. The result is a fine-pitch, magnetically aligned, highly reliable Z-axis interconnection between circuitry and devices. And one of the other benefits to the technology is because we're creating Z-axis interconnection between device and circuitry without having to overload the material with conductive particles like silver, we don't require the same level of loading. Lower loading of those conductive particles means higher performance in adhesive characteristics, mechanical strength, and environmental stability. This is a cross-sectional view of a highly magnified X-ray camera looking at the actual material in real time. Once it's placed onto the ZMAG pallet and put into the curing oven, this is exactly how quickly the particles begin to align. As the polymer epoxy system begins to create a bond, it locks these ferromagnetic particles into a direct alignment, creating not only a very strong low resistance interconnect between device and substrate, but also locking into place these particles provides a very good amount of thermal dissipation, and it provides excellent dielectric insulation between the wires. To bring more to a point to this, we've done some studies with different universities and businesses to show the capability of this material on wearable and different types of textiles. In this case, we're making an interconnect that will withstand repeated stress without losing continuity or interconnection. It's on a TPU material, which is temperature sensitive, difficult to bond to, and requires high cyclic stress. The result is what you'll see here using ZTAC to make the attachment of these capacitive components. We would challenge anybody to find a conductive epoxy adhesive that can hold up to this, maintain continuity, And remember, there's no underfill and no encapsulation on any of these devices.
Last
All right.
slide.
I'm sorry?
Last slide. We are overrunning.
This is the last slide. So this is a quick technology comparison of our materials. This is the standard SMT line that we can run on. And these are testimonials from some of the major OEMs and manufacturers in the world that we're working with today. Sorry, I went a little long, but thank you very much. Please stop by our booth anytime today with any questions or follow-up.